In 1905, Albert Einstein published his theory of special relativity. It revolutionized our understanding of reality. Fundamental qualities such as mass, length, or time, which were considered universal, were now deemed relative. Can you imagine time passing at a different rate for different people? Surely that sounds absurd. I mean, how can it be? A minute is a minute and an hour is an hour. How can it be different? It just doesn't make any sense. Well, the theory of special relativity is here to tell you how. Imagine a scenario with a hover ship going past a stationary observer. There's a person on the ship who is holding on to a ball. For him, the ball is at rest, but for the other person on Earth, the ball is moving at the same speed as the ship. Now if he was to throw the ball with, suppose, speed x, in the same direction as the motion of the ship, then he would observe the speed of the ball to be just x. But for the stationary observer on Earth, the ball would appear to move at speed x plus the speed of the ship. So both observers would disagree on their measurement of speed. But none of them is wrong, because measurement of speed is always dependent on the frame of reference. Every motion is measured relative to something else. There is no such thing as absolute motion or absolute rest. This idea of relativistic motion is very easy to understand and is observable in daily life. But there is a problem. In the early 1860s, James Clerk Maxwell figured out that light is a form of electromagnetic wave and that it moves at a constant speed in any fixed medium. Moreover, in 1888, Michelson and Morley performed an experiment which showed that the speed of light is same for every observer regardless of their relative motion to the source. Why is this a problem? Imagine the earlier situation again, only this time the person who threw the ball throws a beam of light. Now you might expect both observers to disagree on the measurement of speed of light, just like they disagreed on the speed of the ball. But remarkably, both observers would measure the speed of light to be the same. Now how is that possible? This goes against common sense. It's only natural to think that someone who is moving in the same direction as the observed motion would measure its speed to be less than someone who is stationary. But the speed of light seems to defy this. Well, this is where Einstein's theory of special relativity comes in. It explains that time is not the same for everyone. It's dependent on how fast something is moving relative to the speed of light. So what does this mean? Well, it means that time is different for both observers. So the observer on Earth and the observer on the ship measure the speed of light to be the same because their clocks are moving at different rates. This may sound insane at first, but reality is a lot stranger than you might think. And experiments have shown that slowing down of time at high speeds is for real. So each time you enter a fast-moving train or an airplane, time for you becomes slow as compared to someone who's not moving as fast as you are. But why don't you notice these differences? Well, that's because special relativity only becomes obvious when you move closer to the speed of light.